If you are sort of a public official, more like what Simon was just talking about, somebody who would help make policy, would you raise your hand so I get a sense? Okay, good. Good. And then if you work in the port complex, maybe working with Harborcraft or other things, but not directly in the port operations, but part of the port complex, could you put your hand up? So that's looks underrepresented compared to the other hands. That's okay. And then if you are operating ocean-going vessels or you're a vessel operator, would you put your hands up? I know we had Mr. Duke. Very good. Okay. And then if you didn't raise your hand yet, could you raise your hand? Okay. So that tells us sort of the kind of balance, tells me a lot about the balance we have. I only have a few minutes. I know the slides will be posted in the longer run, but my goal is to try to connect with you all. And so I'm going to go ahead and begin. What I've got in the first several slides is essentially background, repeating my purpose for being here. So I'm not going to spend very much time reading you these slides. The gray text happens to be what was in the initial programs and the draft agendas. But the main purpose that I have for today is really to get through my talk so that I can spend time listening to the dialogue that's going on, because I'm one of those others that raises their hands as well. And the only way that we learn is when we hear some of the dialogue. Secondly, the joint purpose we have here is maybe to catalyze innovation. And with regard to that, I'd like to make sure I make a very strong point. It's 2012. And if we just remember briefly to 1912, just after Britain had decided to switch from coal to oil for its Navy, there was still about, 1912, I think it was about 10 or 15% of the fleet was still under sail. They were looking at a century that they had no idea how many things would change. But the die had already been cast, the path, the course had already been set. I think we're at one of those moments. A century's level of innovation is about to be revealed over the next decades. And some of us are already part of it, and some of us are already trying to understand it, and the rest of us are trying to figure out when to get involved. So to catalyze that is a really important purpose for this meeting. And so basically the trick is, the trick for me is to be able to think about what's strategic, watch the relationships build, and see how we can build that pathway, that bridge. Now this slide is I'm going to spend less time on the slide. You'll be able to read it more, but it's really two parts about building a bridge that will help the transformation in all of the freight sector. Remember the shipping innovations that occurred from 1911 through the first fully containerized port in the 1960s. Those innovations didn't just change shipping. They changed every warehouse operation. They changed every trucking network. They changed rail. So we're on a transformation path that's very large. And what we want to do is do more of the good things in the green and fewer of the negative things in the red. But if we do what's existing, then it's all incremental. And so it's important that we sort of look at ways to get to what I call integrated and radical change. The problem, or the opportunity for integrated and radical change, as you can see when you look through there, is the word disruptive. It can be very disruptive. That creates an opportunity, but it's also a bit of a barrier. So our task, really, in the how, on the bottom, is to look at our existing port infrastructure networks, multimodal, freight context. And notice that greening them is very, very useful. But greening what we have in the face of projected economic growth in goods movement will not reduce CO2 emissions. Maybe some of the wonderful things that are happening with moving to lower sulfur emissions, either through technology or fuels, that may create a very long-term sustainable change in the face of growth. An 85 to 97% reduction in sulfur will create a flat sulfur context for the future of shipping for at least a quarter century. before there'll be an upturn again. But with CO2, we're not looking at 85 to 97% reductions in CO2 yet. We're looking at 15% reductions in the new vessel, things like that. So the greening the existing infrastructure is very important, but it actually creates a tension between the destination where we'll need to be in the goods movement system. And so that's like a tug of war between the barriers for acting too aggressively now and the uncertainty with where we want to get to. It's a very big challenge. So what I'm going to do is spend time, my task of course is to talk a little more about the health side of things. So as I proceed to do that, what I'm going to do is cover these 3 points. What are the policy reasons that change is coming? What are the business reasons that this can be a value advantage? And what are the synergies that will make that attractive, or at least maybe sooner than it will happen otherwise? And again, really, that all boils down to what can we do in relationship together. So again, I took some of this out of some of the early documents that maybe some of you had seen, or maybe they were planning documents. But the kinds of things that we can improve, there's a long, long list of things we can improve. And what I chose to do is to revise the wording a little bit and try to just focus on these action words: reduce, improve, avoid, shift, improve again, maximize, innovate, look for resilience, adapt, grow, and protect. And what I'll talk about is how this is playing out in the health context. This top panel here is sort of a weird combination of a bunch of things. It's playing with geography, perhaps a little less disciplined than a geographer would. But the brown stuff is essentially representation of global shipping lanes. The green is simply land areas. And then the blue is where most of the health impacts from the early studies that we did, the first global assessment with sort of a coarse look, not as detailed and fine as can be done on a regional scale. But you can see where generally the impacts are the largest using the blue. And that's a function of really a stepwise process, and I'm going to walk through that a little bit. Down here in the bottom is understanding the emissions and recognizing that there's a set of complex processes that these emissions go through naturally. Some of them fall down out of the sky as particles after a while. Some of them react and turn into new and differently toxic or hazardous pollutants. And then when they come in contact with people or with the environment, then they create an exposure. It's all 3 of those steps that causes impact. So lots and lots of emissions in a place where nobody is maybe is not as bad as having that happening where there's a lot more exposure. And then this is one slide that is outside of my agenda. Just want to mention it really quickly. It isn't just about public health. There are many reasons that we need to think about innovation. It isn't just about CO2. It isn't just about the kinds of things that we're going to be focusing on in this panel. If we think about the sulfur that's part of these air pollution problems, that sulfur typically will eventually fall down and deposit somewhere in the environment. When it gets into the ocean environment, as shown in a North American study that the EPA led and conducted, it can be that 25% of the total sulfur deposition from all sources, landside sources, etc., 25% of that is in these purple areas, and it's attributed to shipping. So the shipping emissions are potentially able to affect coastal aquaculture and other sorts of things as well. Again, I don't want to spend too much time on that. The main thing is shipping matters. It matters in Asia. That's a North American picture, but we just heard the shipping that's going on in the Pearl River Delta and here is larger in a smaller area. There's more shipping going on in a smaller region than what was projected in this model for the North American continent. So the sulfur deposition near Taiwan might be even greater. So how do these regional health studies work? I hinted at it with that exposure processing and emissions processing and exposure graph. But what we really do is we work to calibrate a set of observations from the environment with a set of observations from public health and epidemiology. And these are the 4 steps we go through. This was the results of some emissions modeling that we took an inventory and we ran it through these models. We got the concentrations from what they would look like. And from there, we began to calculate health impacts. And, as you saw in Simon's presentation, conduct comparative analyses to get a sense for what would happen if the current legislation that should take effect at the end of this decade actually comes into play in a fully successful way. What will happen to the emissions? Will they come down? Do they need to come down sooner or more in certain areas? That exposure calculation, the idea that there's a certain amount of particle concentration that's associated with larger scale health impacts among the population that's exposed, is not something that's only done for ships, and it's not something that's really first was done for the public's health. But these calculations, these methodologies were first proven on seafarers, where they found that the engine crew had up to 4 times more risk of certain kinds of diseases than the deck crew. And then they were also shown on rail workers, and they've also been shown for truckers. So the public exposure basis is a set of methodologies that have been proven and proven and proven. My question to you in my last couple of minutes is, where in the world could we imagine the health impacts attributable to goods movement in general and to port-related goods movement in specific, where would it be the greatest? Here's a set of maps of all little circles of where all the ports are around the world. And this is a little ghosty impression of where the emissions are highest according to the recent studies now. Where would the risks be greater? And I think that we can agree that the risk would be greater where the activity of shipping is right next to or in the same community as where many, many people live. So here's a map that's going to take a little bit of blocking out, and I'm going to use, I don't usually use this. The basic idea of this graph is, let me start by talking about the axes. Across the X is the area, the size of which the operation for freight movement is occurring. And the y-axis is the population of people that are living in that same area. So all things equal, if you don't control emissions, it seems reasonable to think that if you can get more people closer to where the freight is moving, to where the goods movement is happening, have people live close to the port, the risks should go up for exposure and health impacts. And if you have more people living in that same small area, the risk would go up. So I come from North America, so let me start here. I was born and raised in California. California has, the whole state of California has a population of roughly 40 million people. That happens to be about the same population as lives in the Pearl River Delta. The Pearl River Delta has an area the size of the San Francisco Bay Area. So if all of California moved to the San Francisco Bay Area, we would have a population that would look a little bit like the Pearl River Delta. But the Pearl River Delta moves some 60 million containers every year. Here in Kaohsiung, it's about 1/6 of that, almost 10 million. I think the slides earlier said next year or the year after they'll break 10 million TPUs here in Kaohsiung. And so there's, what's interesting to me when I think about this very, very simply is that I look around the world and it is here in Asia and in these parts of Asia where you would find the most benefits from considering taking some degrees of action with regard to emissions from ships. See if I can make it go. So why use health as a catalyst? Well, first of all, you don't have to just use health as a catalyst. You can use acidification, you can use energy prices, you can use CO2. The main thing is that goods movement is a solution to some of these issues, especially in these areas of dense co-location between people and the movement of the goods. But what we're going to need is new performance measures to shift from an assessment of concern to a statement of value. How can we, what's going to happen this century? I told you at the beginning what happened last century. This century, these are the 3 things that I think for sure will happen. What they will mean for each of our companies or each of our organizations, that's why I want to listen. The first is that there will be new routes. There'll be shifting routes. We're going to expand the Panama Canal by the end of 2014, or beginning of 2014. There's a chance that there'll be some melting in places right now that are not very navigable. And there's going to be shifts in where people who want things are going to be located, and that will shift routes. Secondly, there's going to be new measures of efficiency. Right now we heard a lot about fuel switching. We heard a little bit about scrubbers and other technologies, and we heard about speed control. The interesting thing right now is most operators, most of us, can envision doing any one of those things and meeting the incremental goals. But I believe in the future we're going to have to do combinations of them, because the goals are not going to be set down here in this little triangle. They're going to be three-dimensional. So we've got to think about all of these things. And this morning there was a great Q&A with Lisa Wonder about making sure the infrastructure was there, because any of these solutions, these are all levers that can be solutions. Switching fuels, new technologies, changes in operations, that's slowing down, logistics, changing the economic demand, it's economic recovery. But if you do any one of these things alone, you won't reach goal, because the other six things will all, the other five things will all adjust. Have you ever tried to push somebody over? They move a foot. We all stay in balance as best we can, so we've got to be able to work those things together. And then this isn't exactly clean here, I apologize. But in terms of policy options, it's too bad this is the only one that showed up. If I only had to pick one, I would have picked the one that's here. It's called Guiding Hand. And what we have is we have a set of choices between letting the economy self-regulate. The market signals, like high fuel prices, create slowing down behavior to reduce emissions. That's an invisible hand signal. No regulation needed. You could have a firm hand where you tell everybody this is the way you must build your ship, how you must operate it, and when you can. Or you can create these incentives that we spend so much time talking about in the first one, which create guiding hand signals. The main idea is that there's a business path to getting to scale, to larger scale behaviors, and there's a technology path for helping serve that. And you can start anywhere you want. In the business path, this is what I tend to think I'm observing in the industry now, is a lot of owner-operator fleets like Evergreen are beginning with vessels they have, the vessels they're in charge of, the ones they control. Then they begin to work with their partners, and they move to their contracted fleets. Then they're getting out there and they're working through the Fair Winds and other programs to get everybody involved, and then share. And then the way to play this game is it's like a game. In fact, I want to make sure I say the word play. The dialogue that this symposium gives us is one of play. That the way to play is that we need to benchmark. Now, benchmarking is just reporting who's on the bench. Okay, that's what we've got with the methodologies that LA's posted on them. LA Long Beach have posted now for sharing. But reporting what the bench is not enough. You've got to get off the bench. But getting off the bench, incremental change is not enough. You've really got to get in and play the game. And then we'll have to figure out how to play to win. So we've got at least two big steps of innovation coming up in the next several decades. And the idea is that we can begin, we can expand, we can grow, and we can share. What I'm going to do in the interest of time is I'm going to tell you that there's more things that I would like to talk about. And there's some modeling that we've been developing that will help visualize possible future solutions, not just descriptive ones. And with that, I'm going to stop. I think I'm over time about 2 to 3 minutes, so thank you very much.
Thank you, Jim. Before I invite our next speaker to the podium, I would like to remind you all in the audience that you can write down your questions and give it to the panel after the end of this
discussion on air quality and human health impacts from marine port and vessel goods movement operations. And I think one thing that I want to say is some of the work that I've done in this area, I've been working on marine and port emissions for more than 10 years now. It has been stimulated by the work of folks like Dr. Corbett, who presented to us in the United States some of these studies of what the impacts were and demonstrated to us that there were real serious public health issues associated with port operations and marine vessel operations in particular. So I'm very grateful for folks like Dr. Corbett being willing to share their work, and it's very powerful in terms of driving us towards collaborations and solutions. So let's move to our first slide. I will be covering some of the work that we've done in the United States that shows the far-reaching impacts on air quality from marine vessel and port operations, and I'll also share some of the mechanisms that we've used to work with partners and stakeholders to find cost-effective ways to reduce these impacts. And some of that's regulatory, and some of it's collaborative, and some of it is technology-based, but all of it has been very interesting and very exciting to be involved in for these 10 years or more that I've been engaged in this. We know that from the other presentations today and the work that's been done that ships like these transport about 90% of global trade. They enable critical exchanges of goods, from food and clothing to electronics and automobiles. Many times the industry likes to say that this is the most efficient way of transport, but it is a way of transport that's come with globalization and global trade. And we understand that in the global economy that global transport has become critical in terms of exchanging goods and food and clothing and electronics and automobiles, but it does have impacts. And it benefits us to think about not only what we achieve from an economic and business standpoint, but to look at the environmental and social sustainability of this vital sector in our modern economy, and really think about how we be more sustainable and how we protect public health and how we work together to make sure that as we do grow and as we do engage in this global trade, we're doing it in a way that makes sense and protects our populations. So one of the challenges is to engage industry, academia, the communities, the people that live in our communities, and environmental authorities to find solutions that are cost effective and, to the extent possible, replicable from place to place. So let's take a brief look at some, and I guess I should say that one of my great pleasures in my career has been bringing people together to work on these issues. One of the things that I was privileged to be able to do was be one of the founding partners in the West Coast Collaborative, where we brought groups up and down the West Coast of the United States together to talk about collaborations and talk about technologies and opportunities for reducing diesel emissions and improving public health, and then to be able to be one of those who brought together the ports of Seattle and Tacoma and Vancouver, British Columbia, to do a voluntary strategy to reduce emissions. So it's been a great opportunity in my career, one of my great joys, to be able to be part of bringing people together to solve these problems. So let's go on to slide 2. Ocean-going vessels are recognized as high emitting by the United States Environmental Protection Agency, the California Air Resources Board, and the world at large through the United Nations International Maritime Organization, as evidenced by rules and regulations and market-based programs that have been instituted. And we know that there are many human health impacts from air pollutants, and the exposure to diesel particulate matter is classified. EPA has classified fine particulate matter, or PM2.5, particles that are less than 2.5 microns in size, as likely human carcinogens. And when I make these presentations, I like to talk about what health researchers have found. I think when we think back to our classes about health and the human body, we all know that in our lungs we have protective mechanisms, little feathery mechanisms called the cilia that filter dust and particles and so on. But what the researchers have found is that the particulates in diesel exhaust are so fine that they bypass those defenses in the lungs and then lodge the particles that are bound up with toxins and heavy metals and other pollutants very, very deeply in the lungs. And many researchers believe they pass into the bloodstream and cause many adverse effects. We see cancer rates that we believe are increased as a result of exposure to diesel exhaust. There are non-cancer health effects that include eye and lung irritation, allergic reactions in the lungs, asthma, exacerbation. We know that around the world there's an epidemic of asthma. Juvenile asthma is particularly problematic in children, and while we don't know exactly what causes the onset of asthma initially, we do know that once you have asthma, exposure to pollutants, particularly fine particle pollutants, can bring on an asthma attack. And we know that that then generates lost school days, lost work days, and even early deaths in people. Nitrogen oxides have health effects in humans that include respiratory irritation, immune system suppression, and asthma exacerbation again. And there have been a number of studies that have been done. Dr. Corbett mentioned a number of those, but many that do show epidemiological evidence that exposure to diesel exhaust is exposed with increased risk of lung cancer. And in June of 2012, the International Agency for Research on Cancer, which is part of the World Health Organization, concluded that diesel engine exhaust causes lung cancer in humans. And that is a very important finding because it does demonstrate that the World Health Organization now has made that link towards lung cancer and exposure to diesel exhaust. So other recent research by the Health Effects Institute about the effectiveness of some of the technologies that are available is more hopeful. We know that there are ways to control diesel emissions with new engine standards. So in the U.S., we've been adopting a number of cleaner fuel requirements and technology requirements for new engines that are produced that show that if you have a truck, for instance, with the 2007 or later emission standards, now the 2010 emission standards, that exposure to exhaust from those vehicles has much reduced the health effects. So we know there are technologies and opportunities for reducing the emissions that are available to us now. So we know that it's our children and the elderly that are the most vulnerable to the health effects of exposure to air pollution, and I think later on I'll share some of the health and productivity benefits that we project from in the U.S. from our efforts to reduce emissions of PM2.5, NOx, and SOx from vessel emissions in particular, and from our suite of diesel emission regulations. But let's think about who this affects the most, and it is our kids, and it is our elders, and we need to be protective of those people, and they're the most sensitive. So others have mentioned proximity to population centers. I borrowed one of Simon's slides here that he showed earlier with Hong Kong, but these are various ports around the world, and we see that oftentimes people do live very, very close to the emission sources. But I also want to be pointing out that while there are hundreds of thousands to millions of people that live within miles of some ports, we also have found in the U.S. that emissions impacts from vessels can impact our air quality far inland as well. So this is a slide that shows some of the air quality improvements with ocean-going vessels if we switch fuels. And in the North American continent, the U.S. and Canada, and because of some small islands off the U.S., France joined together to petition the International Maritime Organization to put in place an emission control area, an ECA. The emission control area does require that there be a step down in the sulfur levels in fuels, initially in the summer of 2012, which just happened this past summer. It's a step down to 1% sulfur fuel, and then ultimately by 2015 down to 0.5% sulfur in the bunker fuels, the fuels that are currently used in vessels. And what our studies at the EPA show is that the air quality improvements with sulfur marine fuel switching extend not just along our coastlines and near our ports, but well into the continental United States and into areas of Canada as well. And you can see from this chart, this shows a measure of the particulate reductions that on a sliding scale shows that, of course, your reductions are closest next to the ports and next to the coastlines, but that the benefits extend far inland as well. And this is air quality improvements, again, with ozone, a different pollutant from PM2.5, and again shows that while the emission benefits are greatest adjacent to ports, they're extending far inland as well. And the sulfur deposition reductions, again, this is something that Dr. Corbett talked about as well. They are extending, most significant along the coastlines, but they also extend well inland because of the transport of pollutants as well. So we also, in the U.S., have air quality standards that we have in place, and when you're not attaining those ambient air quality standards that we set as national targets for air quality, you're considered to be in a non-attainment area, and you can see that many of the non-attainment areas are along our coast and in areas near ports. And again, this is just a demonstration that when we do have these kinds of high emissions, they do equate to locations that have non-attainment for our air quality standards in the U.S. So this next slide is that one that, and the next couple of slides are intended to show what our emission inventories from mobile sources are nationwide. Mobile sources are all of the sources, motor vehicles, trucks, trains, and vessels as well, and construction equipment as well. And you can see from this slide that this is the 2009 inventory on your left, and there you can see that diesel marine from Category 3, the large ocean-going vessels, is 17%. But in 2030, if we didn't control the emissions from ocean-going vessels, this would equate to almost half of the PM2.5 inventory from mobile sources in the U.S. And that's partially because of the growth in ocean-going vessels, but also partially because we've put in place new standards for all of the other mobile sources that reduce their emissions by as much as 90%. So if we did nothing, we would see a much increased impact from ocean-going vessels in 2.5. And this is the SOx inventory. This is an even bigger and more impressive pie here in the 2009 mobile source inventory. Category 3 marine large ocean-going vessels were about 80% of the SOx inventory, sulfur oxides, and then if uncontrolled, would be about 95% by 2030. And in the U.S., we do have a number of ways of trying to reduce air emissions. Some of those are voluntary, some of those are regulatory, and we have social drivers and mechanisms as well where we collaborate and work together to reduce emissions. And one of the things that I mentioned again at the beginning is that engaging with key stakeholders is really fundamental to succeeding in identifying solutions that can be implemented through these mechanisms and lead us to sustainability. Some of the mechanisms do include regulations. As I mentioned, we do have the emission control areas coming into place in the U.S. We do that at the national level and the international level. And then we have regulations at the state level. And we also have voluntary partnerships and community engagement that we've been engaged in. And I'd like to share a few examples of how we use these at a pretty high level, because our team of experts from our ports will share more details in their panels coming up. So a few examples of U.S. EPA marine engine regulations at the federal level. We have put in place national standards that apply to Category 3 engines installed on U.S. vessels and to marine diesel fuels produced and distributed in the United States. And by 2030, when this coordinated strategy to address emissions from ocean-going vessels is fully implemented, it's expected to yield significant health and welfare benefits at a projected benefit to cost ratio of over 30 to 1. And I'll repeat that, the benefit ratio to cost ratio is about 30 to 1 in terms of public health benefits. At the state level, California is our most significant example. California has implemented rules to reduce emissions through ocean-going vessel electrification requirements, plugging into shore power while at berth, fuel switching 24 nautical miles offshore, vessel speed reductions, and from emission reduction technologies for harbor craft as well. They have things like hybrid tugs that are operating now in the San Pedro Bay. And one example of the total cost of regulatory compliance with the California regulations is that for hovercraft regulation, the cost is approximately $140 million over the life of the regulation, but the estimated health cost savings is approximately $1.3 to $2 billion. So a very high ratio, again, of health benefits to cost. So we also have, as I mentioned, voluntary programs and partnerships like our West Coast Collaborative. EPA and our West Coast ports, states, and communities have collaborated to develop and implement clean air and sustainability action plans that you'll hear other panelists talk about. I was privileged to bring together Seattle and Tacoma and Vancouver, British Columbia, and Canada to put a plan together, a strategy, and those plans have improved energy efficiency, they reduce emissions, they improve water quality and habitat restoration while still allowing continued economic growth, and you'll hear more about those from panelists later in the program tomorrow. So also we have some really great examples of going above and beyond emission standards. The last 2 years I've been working with a company called Totem Ocean Trailer Express that runs from the port of Tacoma up to Anchorage in Alaska. And Totem Ocean Trailer Express has been working with me on converting their vessels from using bunker fuels to using liquefied natural gas. And liquefied natural gas as a fuel is 5 times cleaner than even what the ECA, the emission control area requirements for low sulfur distillate fuels, will provide. And TOTE has been working with us on a permit with the Coast Guard and US EPA to convert their vessels to liquefied natural gas over a 4-year period. It's very exciting because we think that this has the potential to be a fuel that is much, much cleaner than what even ECA requirements are. And we now have others interested in an Alaska Tanker Company, which runs the crude oil from Alaska down to the refineries on the west coast of the U.S., is very interested in converting to liquefied natural gas. Washington State Ferries, which is the largest ferry system in the U.S., is planning to convert to liquefied natural gas. And again, this may be a longer distance away in Asia, but in the U.S. we now have a decoupling of petroleum prices from natural gas prices because of shale gas becoming available. And so there's great potential for this to be a money-saving fuel as well as a much cleaner fuel. And if the distribution systems are operated properly, it could even reduce greenhouse gases by 20 to 30%, as well as reducing the conventional air pollutants. So very exciting, and TOTE has just announced that they're going to build 5 new ships, 2 immediately, that will be LNG-powered container ships that will run from Florida to Puerto Rico. So we're quite excited to see that opportunity come. And I'd like to close by just sharing a few of the monetized benefits that are projected through some of the various mechanisms. And the energy efficiency for ships that was mentioned earlier today has the potential to save operators from 34 to 60 billion in fuel costs in 2020. And marine vessel low sulfur fuel has estimated benefits of improved air quality of between 47 and 110 billion. You can between 5,500 and 14,000 premature deaths reduced annually, a lot of emergency room visits, and a lot of cases reduced of acute respiratory symptoms. So again, very great opportunities to reduce our emissions and benefit public health. So more is needed. We know there's a growth in the global movement of goods and a continuing growth in population. And we, according to the United Nations population growth projections, in the world's population could grow from the current 7 billion to as high as 10 billion by 2083. And so I think more and more people at risk unless we take action. So what we hope to achieve out of this symposium is to create opportunities for greater collaboration in Asia Pacific. We want to build a network of experts with the authorities, the ports, the industry, academia, and the NGOs. We want to share experiences, we want to learn from each other, and we want to continue to collaborate and work towards solutions. So thank you very much for having me here and as a panelist as well. Thank you.
Fifth branch of Taiwan Department of Health Centers for Disease Control. He's going to talk about the quarantine of international ports in Taiwan.
Ladies and gentlemen, it's my pleasure to introduce a very different presentation from others. I focus more on the infectious disease control and human health, and not in the environment. This is my outline. I will introduce some matters about our quarantine of the international ports in Kaohsiung. The public health risks, so maybe associated with third person or baggage, cargo, containment, conveyance, goods, and parcel. So the major principle is based on the IHR 2005. So our health response is in order to avoid unnecessary interference with international travel and trade. We have 6 branches in Taiwan, and we here is the 5th branch. We have a Kaohsiung Seaport and Xiaogang Airport. And I divide our quarantine services with 4 parts, and about ship sanitation, port health, passenger quarantine, and conveyance quarantine. Our quarantine based on the quarantine rule of international port. Before the ship arrive our airport or seaport, she had to report before 4 to 72 hours prior their arrival. The measure is by review. However, in one of the 5 scenarios, may have some public health risk. We will quarantine on board. This is conveyance quarantine. Ship quarantine, regard ship quarantine. Most cases were reported by document review, and few cases are quarantine on board. And the aircraft commander shall report the detection of any public health risks to the authority. This is aircraft disinfection. We may ask aircraft to spray some pesticide due to the flight from the area that has specific outbreak. About passenger quarantine. Since there are some strategy to conduct passenger quarantine, include the fever screen and entry port, self-report of air traveler, visualization for traveler, provision of global epidemic information, tips of prevention to travelers. This is our fever screening at the entry port. The infrared thermograph has been set up at international port in Taiwan since May 2003. To automatically screen inbound passengers from a normal body temperature. In the meantime, we evaluate physical situation for fever cases and educate them tips of prevention. If necessary, we will collect an on-site specimen to identify diseases such as dengue fever or sclerosis. When we detect the passenger has suspected communicable disease, and then ask them to fill out the communicable disease survey form. This is our survey form. Depending on the severity of the symptom, contact history, and travel history, we will collect an on-site specimen and transfer the traveler to a hospital if necessary, unless this passenger will be followed up by local health authorities. In order to provide epidemic alert and prevent communicable disease, we provide light box, poster, health alert cards, and pamphlet. The commercial film will be broadcast in aircraft and ship. Okay. About the ship sanitation. When an applicant applies for the ship sanitation certificate, the quarantine officer will inspect the sanitation on board. Area inspect galley, pantry, stores, and so on. Taiwan CDC will issue SSCEC or SSCC based on the evidence of public risks on board. There are four major failures of the ship sanitation. That is, those are vectors and rodent ship, poor shipboard sanitation, stress to food safety, inadequate measures for preventing insects and rodents. This picture explains how we perform ship inspection. The quarantine officer will check the health condition of the area mentioned in the previous slide. Galley, and make sure lid of trash can is put on. this is excellent temptation on board. Okay, so we will issue the SSCC, the Poor Health. Refer to poor health, vector density monitors was performed. Moreover, we organized the sanitary group in international ports. We have organized the sanitary groups in international ports since May 2006. The essential members of the group are Port Authority, Customs, Immigration, Quarantine, Security, Local Health Authority, Surveillance Operator, and other related authorities. Depending on the circumstances, we hold a meeting every 3 to 6 months to plan, coordinate, and implement matters concerning port sanitation. This picture shows the red guards. Red guards hung on the cable, laterally in front and rear of ship. Surveillance and control rats. First, we set mouse cages to catch the rat once a month, and then the ectoparasite. And brought several of these rats we caught. In addition, poison paint is placed here around where rats are most active. We set mouse cages to catch rats. When the rat to be caught, we take those rats back to the laboratory. And we have 2 well-person protective equipment to draw the air blood and examine ectoparasite. This is surveillance and control of mosquito. For mosquito control, we empty containers that are prone to retain water and oil trap, and light trap and survey mosquito density in order to reduce the risk of disease such as dengue fever. Okay, thank you for your attention. I hope you have a nice day.
Thank you, Mr. Chan. Last but not least, I would like to invite my friend Hakan Lai to the podium. Dr. Hakan Lai is working at the School of Public Health of the Hong Kong University. He's been working a lot on health risk communication in Hong Kong, and now he's going to share with us his latest research on health impact assessment related to ship emissions.
Thank you, Simon. First, I would like to thank US EPA for inviting me to come over here and give a speech in here. It's my honor to share what I did about the health impact assessment of the marine emission in the River Delta region. Before I start, I just want to say, from a public health point of view, what the last speaker has mentioned about the diseases and the factors on board. Actually, from an angle of health impact assessment, I haven't thought about this before. And with the increasing number of vessels in the future, we might also have to pay attention to this point of view as well, because of the more increasing number of vessels. They may transport different varieties of vectors around the whole world. So perhaps in health impact assessment in the future, it is also a very good point to also mention. So before I talk about my topic, I would like to base on Dr. Corbett's survey on the law that it seems that most of you are owners of a board, or you work in the public. So maybe I will give you a little bit introduction about myself and also public health and also epidemiology, which I need to spell out a little bit. So my major research, I'm a researcher. I do research about air pollution and health. So my major question is about what are the health effects due to air pollution, and whether how the guideline for the limit can be set, and what levels should be set. So this is all the major questions we are asking all the time. And in my study, I base on a population study, which means I need to collect a huge number of people in the study, and I cannot do any kind of experiment on them because it's unethical. So I have to rely on the recorded data, including the environmental data such as the air pollution data, and also the health records from hospital, such as the death records or the hospital admission record. So you can imagine this kind of study very different from an animal study that in a way you can well control in the experiment, controlling the temperature, humidity, and also looking at all the outcomes under the microscope. But for human, we can't do it this way. We can't ask a human to expose to pollution and then look at the damage in the lung tissues and then assess the health impact. So how can we assess health impact? We have to rely on a huge amount of records. And you can imagine there could be a lot of confounding factors that could affect the relationship we are asking. What is the relationship between the health of human and the pollutants? So, such as I can number of views, such as the temperature, humidity, weather, meteorological factors, and also lifestyle, how people behave and what kind of usual lifestyle they have done in their daily activities, and when did they spend most of the time, and where were they actually exposed to the pollutants. So these are the number of different questions that we confound the research. So we have to look into the statistical models and adjust it for all these kind of potential confounding factors. So this is my major research area, and perhaps I would go into this topic now. So maybe I don't have to introduce too much because you attended this symposium. So just briefly, we have done a study recently funded by Rockefeller Brothers Foundations, and in collaboration with Civic Exchange and also with Simon. And so we did a study looking at the marine emissions in Pearl River Delta, which is located in the southern China, and very close to coast. And Hong Kong is one city is just inside this Pearl River Delta region. So the question is, how can we assess the human health impact due to the marine emission? So first of all, we need to understand what are the total emissions in terms of the inventory, and then we need modeling. We need model results so that we can estimate the concentration and also the exposure level. So Pearl River Delta region in South China is actually why we look at it, because when you look at this chart, I just got the data from where did I get? Yes, from the Hong Kong government. This is a chart showing the container throughput capacity in 1 year in terms of the TEU. So we show very clearly, based on our statistics, that China now showing the largest capacity in terms of the container throughput as comparing to different other countries. So and also Pearl River Delta, if I compile all the data located in Pearl River Delta, it actually is the #1 highest top highest container throughput port or the area. So that is why we have to look at what is the health impact in this region. And also we quantified not just from the ocean going vessel, but also I noted that there are some not a small, very small, not trivial amount of a vessel, but also a lot of it from the river going vessel, because Pearl River Delta is a river delta. So you can also imagine there are a lot of ferries and vessels passing around this region, and also in close proximity to the residential area, but they are not ocean going, they are just crossing the river. So some they are also crossing the river very frequently. And I once lived in an island in the west part of Hong Kong, and I need to take ferries every day from my home to work. And every day I get on the ferry, and then I get on board. I observe the ferries on the port. They emitted huge plumes of dark smoke. I just observe this every day. I can even smell it. So they travel to and from the island and to Hong Kong, just within the Hong Kong water area, very frequently every day. So this is also one of the, perhaps one of the vessels and emission we also need to look at, apart from the trading related to the global going vessels. So the aim of our study, as I mentioned, is to assess the health impact, public health impact attributable to the marine emissions in the Pearl River Delta region, including Hong Kong, Macau, and the 9 prefecture in Guangdong, which is in the Pearl River Delta. So we use there are many methods we have used actually. The one I have to mention here is called the meta-analysis, which is a very standard common approach in epidemiological study, that we pull up all the evidence around and also with a standard approach, so that we can understand what is the overall average of risk due to exposure to air pollution. So you can imagine there are many number of studies in different parts of the world. But we collected in our study, we just collected all the studies in China, in Taiwan, and also in Hong Kong, so that we can give an overall estimate of the risk that can represent the Chinese population. And then we also, based on the model data, as in collaboration with Simon from previously from UST and other university, they produce this model data for sulfur dioxide, so that we can, based on that, to estimate the excess risk, excess health impacts. And also based on, and my question based on that is that we also want to look at the other pollutants. So apart from sulfur dioxide, we also have some other classical pollutants such as particulate, and also ozone, and also NOx. So we have to look at it, and also based on some model results from another studies in US. So we based on a study in California with a researcher from the University of Ivy, and they based on model with air pollution and chemistry, and take into account of meteorological factors as well, and also the geospatial parameters. So we based on their results, we incorporate into the Pearl River Delta, and we take a proportionality principle, so that we can estimate the other, what would be in proportion to other pollutants that would be contributed to air pollution due to marine emissions. And also, that's it. We just based on these statistics and the ratios between river vessels and ocean-going vessels. And here is an image showing you in our health impact assessment, we basically divided into three areas within the Pearl River Delta region. First is Hong Kong, this is Hong Kong, and this is the Pearl River estuary, where there, as one of the slides showed by Simon previously, there are a lot of traffic around this region, and the vessels go from the international going up into here and then go in up to the inland area. So this is another area we're concerned about, which is the prefecture adjacent to the estuary, and some other prefectures within the delta region, which is a bit far away from the estuary. So if we divided these into these by region, we find results like this. That if you look at the sulfur dioxide, now the dark line showing you the ambient level of the sulfur dioxide concentration. The gray line shows you the levels without ambient levels without marine emissions. So you can see without emission, that means if you want to calculate the difference, if you want to know the emission from ship, you can calculate the difference. So we can see the difference actually higher in here. So this is the amount, the difference. This is attributable to the ship emissions. But in Hong Kong, in region A, in Hong Kong, which A represent in Hong Kong, we observe this pattern with the biggest difference. B, which is the locations that are closer to the estuary, we find slightly a little bit difference we can still observe with a seasonal pattern. And C, which is in regions farther away from the marine emission sources, it seems there is no difference at all in terms of the sulfur dioxide. So that is a very clear evidence in here showing that the emissions, if we are in close proximity to the marine emissions, we find the larger exposure. Now these are the results, basically the demographic data in the three parts. I separated the Hong Kong and Pearl River Delta and adjacent to and not adjacent to the estuary, and you can see these are the basic estimated pollutant concentration due to emissions. And then this is a result estimated per 1 million people, and we combine all the 4 pollutants and take into account of the partial correlation, which means pollutants are somehow correlated to each other. We need to adjust for it, and then we observe a figure up to around 172 excess death due to 4 pollutants combined emitted by ships per 1 million people. So taking about these numbers into account, we find that actually most of the death estimated due to ship emissions actually in the whole Pearl River Delta region actually occurred in Hong Kong, up to 73%, even though Hong Kong population is only a smaller fraction of the whole. So to conclude, marine emission control measure could contribute a large reduction in mortality and hospital admission in the Pearl River Delta region, especially in Hong Kong, and there are about 1,200 excess deaths we calculated attributable to air pollution from both type of marine emissions. And finally, just going back to one question maybe we can discuss later on, is that we have mentioned a lot of the technologies approach or technological approach, and even partly mentioned about the what we can do from individuals. And if you remember one of the slides shown by Dennis, the first slide I remember is a container full of powering up a lot of cargoes, and imagine how many cargoes inside on this container are not necessary consumer products. So just another simple question is also how many of you have used have changed your phones in the last 3 years or 2 years, and is it necessary? Is it necessary, or is it another question that part of the commercialization is going to be overwhelmed, and we also need to take into account in saving our world and to love our world. So, thank you.
Thank you, Hakan, for your last remarks. So actually, as you use the ferry regularly and observe the plumes, I also happened that live close to the port area for 2 years, and every day I also observe all the problems coming from the port area that prompted me to look into the problem. So it's quite fun that we have that similarities. Now, we have got 5 very different but related presentations, and it's time for us to open the floor for questions. If you look around the room, we still have, I think, close to 100 survivors who decided to stay till the very end, and I think we are saving the best for you all. So please also send us your questions. After you've been here for a long day, and you must have something you'd like to ask or to dig in to find out more. So please, I've got 3 questions right now, but I'd like to ask you to send me more questions, please. Okay. For the panel, the first one, health impact assessment is a powerful tool to allow government to justify setting more stringent regulations. For governments that do not have much capacity to conduct complicated or rigorous modeling, what would be your advice on the methods or simplified models that could be used to demonstrate health impact of shipping and port activities? Maybe Jim, you want to attack this one first?
Yeah, I think so. Okay. So let me try to be very brief with two ideas, and then the third idea I'll throw in at the end. First of all, one of the things that I observed from all of the epidemiological, all the health risk studies that have been done, whether they've been done for a freight terminal, for a port, for a city, for a nation, or for a global assessment, is that the basic patterns prove out. So if you feel as though your policymakers are not at the capacity to do a full and detailed analysis themselves, I think you could pick a set of these different scales of studies, Simon's study for sure, and mine because I like it, and use that to create the storyline. Second thing, and it's also very easy, is that the bubble map that I produced took longer to make the bubble map than it did to look at those relationships. Until we think of changing technologies or changing the way we operate, it is almost as simple as seeing how closely we're putting most of our goods movement and our workers or our public. So I think you can make the case very simply. Third, I think there's lots of opportunity here to team with people. Simon loves to work with others. I know, because I really enjoy getting a chance to work with them. Any of the people that you've seen during these studies are excited to see new opportunities, to understand the areas where you might have concerns.
Thank you. Dennis, from the government agencies' point of view, do you have any things to add to that?
Well, I think there's a body of evidence that exists out there that's quite compelling in terms of health research and health studies, and there's also an ability to take examples from other places and demonstrate that that body of evidence around risk associated with exposure to ship pollution and diesel exhaust is very, very strong. I know that when I approached my port partners in the region and others, being able to cite that body of evidence was very important. We did then take that and do emission inventories and work to a more refined detail, but there was enough there to get people interested without having to have the detail to start the work and to engage and to start working on reducing emissions. And I think I would side with Jim. There's just a lot of information out there that you can work from, whether you've got a very detailed study.
Actually, I also want to ask Mr. Chen, because I think based on all the presentations here, it's quite obvious that there's a huge impact from ship emissions, port emissions on public health. Is there any steps that your office has been taking to start thinking about this important area? Is there anything, because this question asks about sophisticated modeling, but maybe that's something for the future. But at the moment, is there any ways that you've got people getting interested in Kaohsiung about port-related emission or ship-related emission, and what are things that maybe the health office in Kaohsiung is going to do? And can you enlighten us on that?
In fact, it's not our duty of the health authority, because the air pollution or emission is the duty of the EPA. So I can answer your question.
Okay. Now, but I understand. Now, but I think as someone living in Kaohsiung, everyone would like to have clean air, clear skies, less emission from ships. So maybe I think even if we work for I work for an NGO, you work for a government agency, but after all, we're all residents of the city. So let's say we should come together and say we need less pollution coming from ships and ports, and try to do something to put pressure on the government, and then maybe the Taiwan EPA, the agency, will start doing something, right? Okay. Haven't you have anything to add to this question? No. Okay. Thank you. Now I have another question about LNG fuel, and they are concerned about cost. Now LNG fuel is more expensive than the heavy fuel oil that ships been using. The question is, who will pay the money? I suppose is who will pay the extra cost to switch to a cleaner fuel like LNG, and do they have any incentives for a ship company to do it as we handle against?
Well, I think the unique thing in the United States is that liquefied natural gas is less expensive than the bunker fuels, and so that economic imperative there, because we now have discovered the vast reserves of natural gas in shale deposits in the U.S. The price of natural gas has decoupled, has separated from the price of oil. And so why I said this is maybe 10 years or more away in Asia is that they're looking at the potential for shale gas in Asia as well. Right now, it is more expensive in Asia, but in the U.S. it is less expensive. And so we're taking advantage of an opportunity, an economic opportunity that's also an environmental opportunity, which may come at some point.
Quick to add to that, even where LNG may be closer in price or higher than the petroleum alternative, LNG has some opportunities to fill a niche, to serve a purpose. Shorter distances, ferries, regional activities, and higher value cargoes where the price of the fuel is able to be captured in the freight rates. For example, the cargoes going out to U.S. territories need to be carried in certain ways to meet U.S. regulations. That may justify, even under changing LNG prices, a long-term investment by Total. In Europe, there's at least one tanker company that's looking at reinvesting product tankers in LNG. That gives them open access under all potential regulatory regimes without reinvesting in their fleet twice or three times in 2 decades.
I would also add that there's a possibility that we're seeing a paradigm shift in the U.S. For years, we thought that there would be LNG import facilities bringing liquefied natural gas into the U.S. And now what we're seeing is great interest in export of liquefied natural gas from those same terminals Asia and other places, and that may be lower cost than the current supplies that are available.
Thank you. I have one question asking. We have heard of major health impacts from marine vessels from all this presentation. Do you think it is possible to avoid these marine-related impacts from all the major pollutants like NOx, SOx, and PM with voluntary measures? Or will more dramatic regulatory requirements in Asia be needed? Anyone want to try? Of course, I need to ask you first because I'm not simple. Okay. Well, now, okay, I will answer that. When it comes to voluntary action, without regulation, I think it's really up to the polluters to decide how much they would like to take up, or whether they would like to take up the ownership of the problem. And in that process, we can see, for example, in Hong Kong, there are a number of shipping lines who are very keen to step forward and say we are part of the problems. Let us become part of the solution. So they are willing to pay up, they are willing to come up with voluntary actions, they are willing to make the first baby steps so that everyone becomes aware of the problem. And with that, maybe the government will then come into the discussion onto the table and discuss and think about ways, maybe incentives to be the next steps to bring the ships forward. And then through regulation, everyone will be on board. I think this is for fairness. This also kind of solve the concerns that if I spend more money for something that's not regulated, my competitor may have an advantage over me. After all, shipping sectors is a very competitive sector. So if you are not on an even playing field with your competitors, then you're in trouble. We are talking about sustainability. So maybe first of all, the company has to be financially sustainable first before thinking about environmental sustainability as well. So these are the things that I believe is very important when it comes to the steps towards regulation. Of course, it is great that we have some companies who would like to voluntarily do something, paying from their own pocket. But if we cannot sustain that, maybe after 1 year or 2 years, when the pressure on looking for more profits or at least break even or try to be close to the competitors in terms of making money, when that pressure becomes more and more important, just like the last 2 years, actually it becomes really difficult for them to continue with all these voluntary actions, and they will then ask the government to regulate. It's kind of strange that money-making business asking Hong Kong government to regulate that, but that's true. I think because they have a point there. Dennis and then Jim.
So I would say that it takes a combination. It takes regulation. Regulation sometimes spurs innovation as well. The LNG, the liquefied natural gas conversions for Toad and some of the others would not be occurring if we had not put in place an emission control area that had higher costs for bunker fuels, for distillate fuels versus bunker fuels. So people were looking for a lower cost solution that also had lower emissions. And I would also say it's not only marine vessels that are part of the problem, it's locomotives, it's drayage trucks that haul the cargoes to and from the port, it's cargo handling equipment. So in many of those areas, the diesel engines last for a long, long time. People buy diesel engines because they're durable and low cost, and so if we waited for new engine requirements and new regulations there, we might be waiting 30 years for an engine to be retired. So the voluntary measures oftentimes are getting emission controls or replacement of equipment with incentives and collaboration, and that's where you'll hear some more from some of our ports tomorrow about what they do.
In some ways is, how big a target do you think we need to meet, and how soon do you think we need to meet it? Because that, I think, brings in the clear role for policy. Two quick examples, and it goes back to that triangle on firm hand, guiding hand, and invisible hand. In the early part of the last century, we had an invisible hand incentive. There was a market lineup. It was perfect market storm to switch to more efficient vessels that were larger, faster, cheaper to operate, and had better efficiencies. And it took from the early 1900s until the early 1950s, at least, before containerization, before we had the majority of the fleet converting to that. 5 decades without any barriers other than the timing, which was in the invisible hand. The industry had its self-regulation. If we need to meet global climate change targets, if we need to meet public health targets, then we may need to have policy to move faster. Secondly, if we don't have all of the perfect conditions for innovation in the market, then we need to establish some of those. One of the wonderful things that's happened since MARPOL Annex 6, the IMO regulations requiring at least as a default cleaner fuels, is now there's an entire industry of sulfur scrubbers who are working hard to see whether they can undercut the price and overachieve the performance standards. There was no market for them to sell a scrubber until the regulations.
Just to add, I would have thought the public health angle should be also emphasized in this, to answering this, because in the past we don't have sufficient evidence looking at the health effects due to air pollution or the emissions from marine. But now we got the evidence, and also we find associations and demonstrated well by Dr. Corbett in his paper as well, and a number of studies afterwards. So, I mean, from the health point of view of human, this should be stressed more and emphasized more. That is an urgent agenda that we need to take into account, because otherwise would be damaging the next generation, and also those in a fetus stage, not those are unborn, would be also affected as well.
But I think Hakan's got a very good point about how pressing this issue actually is. But the thing is, for example, if we want to go for an emission control area, we cannot do it overnight. It has to take a few years, maybe, based on the other experience, to get us to that finishing line. And if Hong Kong, together with Guangdong, the Pearl River Delta area as a whole, is to become an emission control area, then we also have to get a blessing from Beijing, because after all, they are the full member of IMO. We are not. Hong Kong is not. It's just an associate member. So we cannot initiate, or we cannot apply to the IMO for an emission control area in Pearl River Delta region. So it takes time. It would take a bit more research. And so back to Hakan's point about public health. Supposedly we cannot wait. I mean, it's kind of harming people on a daily basis. So what can we do? So maybe in the interim, before we get to that ultimate goal, which will bring us the most of the emission reduction and health benefits, we still have to come up with some measures, strategies, and regulations. I don't know whether voluntary action would be that effective in that timeline. I really don't know. In Hong Kong, we have some good examples that I think, I mean, it's loud and clear in this room that has been mentioned in the last panel, that money incentive is very important. So that the business sector is willing to start thinking about doing something more green. How can you add one?
Yes, just want to add an example. Actually, things can be done very, very quickly. Remember the SARS at that time. What the government has done, they can do things very, very quickly and develop strategies and solutions within 1 year, and subsequent years they have good protocols in all hospitals and also to public health messages. So that actually technology is also available. So it very much largely depends on the willingness, I would say so.
Yeah, sure, political will to make a difference. Now, Hakan, hold on to the mic. There's a question for you, also about public health. Now, the question asks, what is the scientific ground for your conclusion, which mentioned that 1,202 people died due to ship emission pollution? Right.
That is the based on the meta-analysis, which is a study pulling up all the a number of epidemiological studies in China, Taiwan, and Hong Kong, and then we base on those estimates to calculate what would be the difference of what would be the health impacts due to exposure or to pollutants emitted from the ships. So that is an association. What we are based on the association, on the effects and also the exposure. We can't go to the point that this is a causation, because in the public health or epidemiological study,
it's hard to say anything absolutely causal unless we have a very clear microscopic evidence on what actually happened to the blood and lung tissues, and then with assessment of many other criteria such as temporality, but of course in epidemiological studies we have a very good scientific foundation how to assess these associations and in what extent towards the causality that we are talking about. And I can guarantee you that in WHO, they're setting the guidelines. They also based on a lot of studies from epidemiological studies. So this is a very up to the standard approach to look at this as a kind of answering your question, scientific basis.
Okay, thank you. Anyone who want to add any? Okay. Now, Mr. Zhang, in your presentation, you make us recognize that there are other important aspects of sustainability, for example, vector control, invasive species, so on and so forth. These are all very important when we consider the broader sustainability practice in the port area. In your experience, how easy or how difficult are you working closely with the shipping companies? Because, for example, you have to get on board to do inspection. Maybe there are a lot of documentation. You have a lot of regulations that you need to enforce. Can you share with us your relationship with the shipping community as a whole? Because as we are doing emission controls, there are measures or regulations that also require the agencies or the inspection officers to have close contact with the shipping sectors. And as NGOs, we also have to work a lot with the shipping sectors. So maybe your experience will also enlighten us in that direction. Mr. Zhang.
I think we should have a well-organized group in the port city. And I think maybe some operator or ship agency can document the pollution maybe they produce, and I think we're just in the beginning, so maybe we have to organize our group. Yes.
Okay. Thank you. Thank you. We still have 5 minutes to go before the final wrapped up. Is there any more questions from the floor? Or I will start naming names. No? No? Now, may I ask, since we're in Kaohsiung and we're talking about, port emissions control and ship emissions, we've heard from, Mr. Zhuang a lot about the inventory and also the plan to reduce port and ship emissions. Can you tell us a bit more about the process of, getting towards regulation and make sure that enforcement will be, perfect? Can you share with us? Now, because you are not asking questions, that's why I'm asking questions. I know it's not very traditional, but.
Okay, I think you want to do this. I think step by step. You have to more patient. Okay, that's my answer. Thank you.
Okay. Now, Mr. Zhuang, the reason I ask is, I think in the last panel, one question was, do anyone know if there's any Asian ports that's got a lot of regulations? My understanding is right now it's only in Taiwan, with regulations or plan or strategy that's been rolled out. Of course, you are not there yet in terms of getting the regulations implemented. For example, in Hong Kong, we only have incentive schemes. We are now talking about regulation. It will be rolled out soon. In Singapore, they have also intense incentive schemes. I have no knowledge about similar regulations in any Asian ports or cities right now. So I think you are the only one with a very concrete plan, and that's why I asked you that question, just for the benefits of the audience. Jim, do you have anything to add to that?
Okay, maybe I can stand to here. I think Taiwan EPA was built up 25 years. So I think most of the stationary air pollution control regulation will built up step by step. So I think not only for ocean-going vessel, but for the port area, we have the regulation. I think 15 years ago, 17 years ago, not just beginning, you know. So I think we can use the same regulation for port areas, stationary air pollution source, or like cargo handling equipment. We ask for they have to use low sulfur fuel, low sulfur content fuel, below 10 ppm, and also ask for the diesel truck that traveling on the ocean or on the port. They have to use the low sulfur fuel. So I think this is not just beginning. This a long time ago.
They are not voluntary. They are regulatory, right? They're
Yeah.
mandatory. They have to switch.
Yeah.
Okay, good.
Okay.
Thank you. Now, any more questions from the floor? I have another question. So if you don't ask, I will ask. No? No? Okay, now. Yes? Good, thank you.
It's a question about not really related to public health, but more like I know in California you have established regulations to promote the AMP, and you want to, I guess it's like by 2015 that you would need all the ships, 15% of the ships need to use the onshore power. And could you, Mr. McMillan, can you tell us more about how you promote this whole program? Since like in Taiwan or in Kaohsiung now we really want to promote the AMP, and what is the barriers or like the total cost you have to put in all the ports in California? Thank you.
Well, I think probably our Port of Los Angeles folks may be better equipped to answer that. I think that part of it is regulatory, but there have been incentives as well. So, Lisa, maybe you can speak to that a little bit more.
That is correct. Our California Air Resources Board, starting January 1st, 2014, is going to require 50% of ship calls to plug into alternative maritime power. And we're working very hard at the Port of Los Angeles to provide the infrastructure that is necessary for our shipping lines to be able to plug in. So currently we have 4 container terminals in our cruise lines that are equipped with alternative maritime power, and we're working to get 20 more approximately AMP stations. We consider it as the landlord. It's our responsibility to equip the land side, but it's also the shipper's responsibility and the ship's responsibility to have the infrastructure on their ship in order to plug in. And the cost of that on the ship side, it can be about $500,000 per ship to retrofit. It ranges between $200,000 to even higher than $500,000 US to do that on the ship side. And on the terminal, we are receiving grant funding from the state of California to assist us, but it's millions upon millions of dollars to do that on the shore side.
Okay, yes, Richard.
Perhaps Richard Sinkoff, Port of Oakland. Going back to your question, gave us some time to think about it. I'm wondering, in the absence of sort of the regulatory structure, whether we shouldn't think about the other tools that have moved this issue forward. For example, there are 2 other things that we haven't really talked about, although I think we had a question. One of them is the tool that we were discussing at dinner last night, which is a health impact assessment, which is different from a health risk assessment. And the other factor that I think played a big role in the United States in moving forward the discussion about health risk was the executive order on environmental justice. So there are other policy mechanisms, there are other tools that we might have in our toolkit before we have a complete regulatory framework. So perhaps we can just have some of the panelists talk a little bit about health impact assessments, the role of the executive order. I can talk a little bit about that if the panelists don't want to, or but I think we have to look at the full range of tools that we have: soft policy, hard policy, incentives, to move this issue forward. Because if we pick only one path, I think there are just lots of risks out there that may not succeed. So I think you have to have a multi-pronged approach.
So, Richard, with apologies, I'm going to hopefully segue a little back to that, but I want to pick up a little bit with the question about the auxiliary alternative marine power investment question in new ports. The fact that there's an investment burden by the vessel operator is very important, and I think I would try to think with the business sector to help answer your basic question. If whatever the regulatory regime is in California is going to require X% of the terminals and vessels to be converted, if I am a vessel operator, and I used to be a ship's engineer before I was whatever I am now, and if I was working for that shipping company and they had to invest in alternative marine power for only one port call or two port calls, I would be looking very hard at finding port partners where I could plug in more than one time and reduce the per plug-in cost of that investment. So I would look for terminals and berths and carriers who have strong ties out of those hundreds of routes that were shown here. At least the several that are headed toward the west coast of California in a few years will be cheaper per plug-in for that operator to invest in those vessels. So I'd try to bring the business folks on board. It's a little bit getting back to Richard's question about looking at not necessarily hard and soft policy, but looking at the public-private business partnership that can help reduce the barriers to timing of investment.
Thanks. Question from Richard, and I just want to pick up another part, the role of health impact assessment in this whole discussion. My opinion is it is somehow in between science and policy, that how to bridge up science and policy. And but there's still some limitation in the health impact assessment because it's much relied on the availability of the epidemiological evidence, and whether such as I could explain further, such as whether you have presence of long-term effects of the health impact or just only the short-term effects, because we all know the long-term effects are usually in a magnitude of 4 to 10 times higher than the short-term effects. So if we got the long-term effects and assess the health impacts based on the long-term health effects estimates, that the estimation of the whole impact would be much larger. But it would much depends on whether we have the evidence locally, because in different parts of the world we have reviewed the epidemiological data of different classical pollutants and noted that actually it's not as simple as we thought before, which looks as if a linear dose-response relationship. Actually, it's not linear. It's non-linear. So what mechanism behind that is still subject to further study. And if we want to really look at that, I would I would suggest the whole academia in the whole world, we all contribute to provide the estimate so that we can give a whole range or spectrum of estimate of what happened and what is the total amount of health impact. That kind of estimate of the range of health impact will be independently estimated by different institutes. So you can get an upper and a lower boundary estimated by different university or institute research. And so that would give a broad, even more objective estimation of the total amount of health impact, irrespective of the differences in methodology, statistical analysis, and the assumptions. So that would be a kind of a strategy I would suggest in the role of health impact assessment in this discussion.
Okay, thank you, Hakan. Any more responses from the podium, from the stage? Dennis?
Just briefly, Richard mentioned the concept of environmental justice and the executive order on that. It has become a priority of government in the U.S. to address communities that often bear a disproportionate burden of air pollution. These are oftentimes low-income communities. People with maybe more money have the ability to move away from the pollution and have their homes away from where the impacts of pollution are the greatest. And so it's become a priority of government to give a voice to the people that may be underrepresented politically and not have the income levels who live close to the sources of pollution. So it has become a priority to take steps to address that disproportionate burden by looking at what ways government can address that and respond to that. So just wanted to introduce that concept of environmental justice that has become a priority of government in the U.S.
Thank you. Richard, do you want to follow up?
The only thing that occurs to me, because I think we're having a great discussion here, is that the concept, once we saw a lot of modeling today, and you're able to, through the modeling, you're able to see certain patterns emerge. And I think that pattern, when we analyze the pattern, it gives us the opportunity to define the problem, perhaps, in another way that can add to the science. So what we certainly went through in the United States, and in California especially, as we began to see the importance of trade and logistics to our state's economy, we also began to study the patterns of health risk, and we began to ask ourselves, why are they clustering? Why are these problems clustering in certain areas? And it was through that we began to define this concept of environmental justice. So again, I think the question that was raised was about sort of the role of regulation and whether if we're not ready to adopt a regulatory scheme, how can we advance solving this issue? And I think we can advance it by bridging, I like that word very much, bridging between science and policy and the studies that are done in academia, so we can see certain patterns that we may not have seen before, and then ask ourselves, what is this telling us and how do we define it? And environmental justice as a concept really has been a very, very important tool that we were able to deploy before we had the full regulatory scheme. So I think the conversation has given us a way of thinking about bridging all the different disciplines that come into play, and then asking ourselves, is there something new that we can define, and then apply that to the solution. Thank you.
Thank you, Richard. One last remark, okay?
If I may, I want to use a broader set of terms than environmental justice. A large volume of global trade passes through the Straits of Malacca and Indonesia, and environmental justice in the U.S. context has a certain socioeconomic real estate sort of context. But we're looking at global shipping lanes, that are passing coastlines on every continent. Some of them are passing Hong Kong, which perhaps is got a certain economic status that isn't lower than some of the other areas that that freight is coming from or going to. There's the Panama Canal, that area. There was a bunch of wonderfully affluent and non-affluent Panamanians that live there, and so really it's about the inequity, if you will, between whose purpose it is to move the goods and who, by virtue of their location only, can benefit from cleaner goods movement. And I think that it's important that it be environmental justice in the U.S. context, but I think I can imagine places in the world where the U.S. definition of environmental justice would be inverted, and it would still be worth doing.
Thank you, Jim. I think we've got all warmed up, and we've got some brilliant discussion, but we are about time to wrap up. Before I invite the speakers to leave the stage, please give them another round of applause for their presentation. I would now like to invite the speakers to leave the stage. Now, well, thank you so much for staying till the very end. I'd like now to invite Mr. Louis Troche of US EPA and Dr. Liang from EPA Taiwan to get onto the stage and to summarize the key point that we've come through and discussed today.
Thank you, Simon. First of all, I would say how grateful we are to all the panelists today for sharing their time and expertise to us, and how grateful we are to all of you for staying with us the entire afternoon and participating in the conversation through your questions and comments. When we worked together with Kaohsiung EPB and with Taiwan EPA to design this forum, we had a couple of objectives in mind. Our first objective was to hear from the different stakeholders, and that is environmental agencies, health agencies, port authorities, shipping companies, and NGOs and academics, their different perspectives on what it takes to achieve sustainability in shipping and the movement of goods, as well as managing ports. I think we made good progress in that conversation today, hearing from all of you. We have learned that it takes working on air, water, waste, looking at disease vectors and invasive species as well, and also looking at the communities and engaging the communities. There are a couple of items that we didn't touch on today that I hope we will touch on future conversations, such as climate adaptation and resiliency, but we'll save that for tomorrow. So I'm very pleased to have heard the conversation today. Our second objective was to share what we know to date on emission impacts and human health and how it is being addressed in different parts of the world. I think we made good progress in that conversation as well. When we put together this panel, we had the objective of bringing together all of you guys with our guys in the U.S., but also welcoming our partners from Indonesia and other ports in the region, because this topic is not only of interest to the U.S. and Taiwan, but also to mainland China, to Singapore, to Indonesia, and to our partners all across the Pacific. So we're hoping that today's conversation is just a starting point to strengthen our network of experts, to share our expertise, because by sharing our expertise, we not only help you achieve your objectives, but we also learn from you as well. For example, we know at US EPA we have a lot of experience, but we also learn on a daily basis from our partners. Tomorrow we're going to spend a lot of time, and it's going to be a lot of conversation on current practices that are successful, that are being implemented in the US and in Asia and in other parts of the world. But we also want to talk about what are the benefits, what are the results, how much is it costing, and how sustainable it is. And we have our peers here from the ports in the US, as well from some other ports, who have brought with them that information. In the afternoon, in the morning, we're also going to have a panel on what is the institutional capacity that helps us implement sustainable environmental programs and achieve sustainability in the long term. I think this is a very opportune conversation because we're very pleased to see Kaohsiung moving towards sustainability. We've always been pleased with Taiwan's commitments to sustainability and green economies, and the fact that Kaohsiung shared their vision today for the new bay is an opportunity to share expertise across the Pacific and help each other advance our goals. Finally, in the afternoon, we'll have a conversation on what are the next steps. How can we work together to develop the next set of solutions? Now, we're hoping to continue this conversation tomorrow, but also prepare for a stronger conversation in the summer of 2013. My colleague Penny McDaniel will tell you more about that tomorrow. So with that, I would say thank you to all of you, and I would pass the microphone to my esteemed colleague from Taiwan EPA, Dr. Liang. Thank you, everyone.
Good afternoon, ladies and gentlemen. On behalf of Taiwan EPA, I would like to take this opportunity to thank AIT, US EPA, and Kaohsiung City Government to organize this important event. Well, time getting late, I just want to share two pieces of information with you. The first, as you may be aware, Taiwan EPA entered an environmental cooperation agreement with the US EPA in 1993. So we are celebrate 20 years next year. A series of event and activity will be held both in Taiwan and the US. So certainly all the audience are welcome to participate in the future activities. Secondly, I just returned from Tianjin last night. I went to Tianjin to attend the second Blue Economy Forum organized by China. There are 15 member economies attend the event, and we have a very extensive discussion on blue economy. Unfortunately, major APEC economies, including United States, Canada, Australia, and Japan, are missing. So I'm exceptionally glad to see so many of our American friends gathered in Taipei today to discuss, very enthusiastically on sustainability between Taiwan and the USA. So I'm grateful, and I believe everyone agrees with me. We have an excellent program this afternoon. And trust me, tomorrow will be as good or even better. So I will see you all tomorrow. Thank you.